Okay, so we're going to talk about box plots in this video, and in AP statistics, I would say that this is the most important graph. We are going to use it over and over again, not only in this unit, we won't see it that much in probability, but when we go to unit 4 during the second semester, we'll be making them again as well. So I highly recommend that you not only get all of this, but you actually pay attention and totally own it, because there are going to be lots of questions on box plots that come up. So let's go back a ways. Earlier in another video, we talked about the 5-number summary. All right, so we had a 5-number summary, and we said the 5-number summary consisted of the minimum value of the data set, Q1 or the 25th percentile, the median, Q3, which is the 75th, and then the maximum. Well, it turns out a box plot is a visual representation of this. Here's a minimum. This right here represents Q1, which is a Q and the 1, the 25 percentile, or first quarter is the 25th percentile. This is the second quarter, or the median. This is the third quartile, and this is the max value. All right, so we have a min, a Q1, a median, or a max. I have to make one caveat to that. This is the median. I mean, this is the minimum value if it is not an outlier. If this over here, if we had an outlier, it would not be connected, and this would be. If we had an outlier on the upper side, this would be the max. This would be the max, and it would not be connected. So if it's an outlier, they're not going to be connected. And we will see those not in this video so much, but as in a following video. So we're going to make sure that we can identify the parts of this, because it's just fairly easy to do. And there are going to be questions that you need to know. By the way, some of you may have seen this. I taught this when I was in middle school. But prior to becoming a teacher, even though I have a master's in applied statistics, I had not seen it in middle school, high school, college, or in my master's program. But it's just another data distribution. And quite frankly, it's one that the PSAT uses to put their data out to students, and the way that they do with the SAT as well. So this is a very, very common distribution, or has become very popular. Some people refer to it as a box and whiskers, where these are the whiskers. So identify the highest value. All right, the highest value is about 35, and so we're just going to call it 35. When I look at this, it says identify the lowest value. Well, the lowest value of the graph happens to be 26. Identify the median. This is the median right here. So this is at 29, that little bar. Find the range. Well, the range is going to be, remember, the range is always going to be largest minus smallest. So in this case, it's going to be 35 minus 26 equals 9. Largest minus smallest. All right. Identify the first quartile. Well, the Q1 is here at 28. And that means that 25% of the data are less than Q1. All right. The third quartile is Q3 right here. And 75% are less than that value, so 75% are smaller than 32. Our next thing says identify the interquartile range. Well, you need to know the formula. All right, and the formula for interquartile range is Q3 minus Q1. So that's going to be 32 minus 28. And that ends up giving a value of 4. All right, and if we look at there's 4 here. All right, the next thing, it says 75% of the data are above what value. So be careful with that. First off, I should say this represents 25% right here. This little section here also represents 25%. This section represents 25%. And this section represents 25%. So 75% are above what value? So 25, 50, 75. So 75% of the values are above 28. All right. Then it asks us to list all combinations where 50% of the data lie. Well, the first 50% would be 26 to 29. So 26 to 29 would be, excuse me, let me try that again. 26 to 29, that's the first 50%. The next 50% is right here, 28 to 32. That's the middle 50%. And remember, the middle 50% is called the IQR. The next 25% is 32 to 35. Then the very last question says, find the mean. Okay? And at the very bottom of the page, box and whisker plots do not identify the mean. So this is a trick question. You cannot determine the mean from a box and whisker plot. All right? So moving on. Identify the highest value. Oh, highest value is 35. Identify the lowest value. Lowest value is about 25. Identify the median is about 32. Find the range. Well, the range is largest minus smallest, so 35 minus 25 is 10. Identify the IQR. To do that, to find the IQR, we're going to have to go Q3 minus Q1. So in this case, Q3 is right here. This is Q1. So 33 minus 29. So our IQR is 4. Finally, we get to the point of how small must a value be to be considered an outlier? Well, to be an outlier on the low side, we're going to have this formula, and this is one you'll need to memorize. X has to be less than Q1 minus 1.5 IQR, right? And remember, IQR is just Q3 minus Q1. Well, we previously calculated the IQR and said that it was 4. So at 1.5 times 4, and we said our Q1 was 29. So 29 minus 1.5. So X has to be less than 29 minus 6. So X has to be less than 23. Please notice I said less than. If it's 23, it's not an outlier, right? So it has to be less than 23. On the high side of the data, our formula is a little bit different. Follows the same format, and our formula is going to be Q3, or the third quartile, plus 1.5 IQR. And X has to be greater than that. X has to be greater than Q3 plus 1.5 IQR. And IQR, once again, is just Q3 minus Q1. We previously said that our IQR was 4. So we have 1.5 times 4. And we know that Q3 is 33. So X has to be greater than 33 plus 1.5 times 4. So X must be greater than 33 plus 6, which means X must be greater than 39. If it's 39, it's not an outlier. It has to be larger than 39. All right, so that gives us our data values for anything that has to be an outlier. So anything less than 23, anything less than 39. Finally, is this data skewed? Well, this represents 25% of the data, and it's narrower than this. So my data has been pushed together here, which means it had to get tall. And this looks like it's been stretched out this way. So if I were to draw something like this, I would say, you know what? If there were 20 data points, 10 would be here. So I have to fit 10 data points in there. And over here, I also have to fit 10, but you can see that it's a lot farther stretched out. So this one is skewed. And in this case, it's skewed to the left, right? It's skewed to the left, which means the mean is below the median, all right? The mean will be to the left of the median, or the mean will be less than the median. Looking at this next one, identify the highest value. All right, well, this doesn't line up very well, but our highest value is about 20. Okay, and our lowest value is about -5. The median, maybe about 2, somewhere close to 2. Find the range. Well, remember, the range is the highest value minus the lowest value. So in this case, 20 minus a -5 is 25. Our IQR in this case is going to be Q3 minus Q1. Q3 is at about 11 and Q1 is about -1. So it looks like we're going to have 11 minus a -1, which gives us an IQR of 12. So calculating outliers. How big or how small will a value have to be in order to be an outlier? Well, remember, X has to be less than Q1 minus 1.5 IQR. And remember, IQR is Q3 minus Q1. So Q1, we said, was -1 minus 1.5. We already calculated an IQR. We said that our IQR in this case was 12. And remember, that's just Q3 -11 minus the -1. That's where that came from. When I go about solving that, I end up getting X is less than -19, because this ends up being -18. So -19 would not be an outlier, but anything less than that, anything more negative, would be an outlier. On the upper end of the data, we are looking at, for our formula, X is greater than Q3 plus 1.5 IQR. Remember, IQR is Q3 minus 1, or Q3 minus Q1, I should say, which in this case was 11 minus -1. So our IQR was 12. So we have 1.5 times 12. And then our Q3 value, we said, was 11. So in this case, it's going to be 11 plus 18. So we need a value greater than 29. So X would have to be larger than 29. Excuse me. There appears to be a typo here. Sure enough, X would have to be greater than 29. All right. As far as skewness, if we look at the graph, it looks like it's been pulled to the right. So it's stretched to the right, which means the data is skewed to the right and has a mean above the median. So our mean value would be larger than our median. All right, and that's how you interpret box plots. Quick video. We're going to spend more time in the next video. We're actually going to create box plots and calculate outliers. All right, thank you.